All right, let's look at the area under a parabola. All right, so let's say you have a parabola or a quadratic function, f of x equals ax squared plus bx plus c. And what we want to do is we want to find the area under the curve, under the parabola, in terms of three values. Value at the left-hand point, value in the middle, and the value at the right endpoint. All right, so let's do that. All right, so let's say we want to find the, so for simplicity, I put the region around the origin, and it goes from negative h to positive h. So x0 is set to be negative h, x1 is the middle guy, which is 0, and x2 is equal to h. So we want to find the area. But let's find the values at left endpoint, the midpoint, and the right endpoint. All right, so all you have to do is plug in. So x is negative h. So if you plug it in, so plug in here, so you have a h squared, and put negative h there, so it's going to be a negative bh, and then you have the plus constant c. All right. F of x1 is the middle guy, which is 0, so you're just going to get c, 0 plus 0 plus c. So I'm just going to put c here. All right, f of x2, so we plug in h, so only difference is the sign, so h squared plus bh plus some constant c. All right, so we got that. All right, so in order to find the area under the graph, so we can just set up a different integral. So it's an integral. It's going from negative h to positive h. So we're going to go from negative h to positive h. All right. Then function is a quadratic function. So I would put ax squared plus bx plus c, and with respect to x. All right. And we can do a little bit of trick to save some time. All right, so since it's going from a negative h to positive h, any odd function would produce 0. So you can see that here, b of x is an odd function. So this is going to produce 0. So you can actually scratch that out, right? Then since the other ones are even functions, so you can just do a half of it and multiply by 2. So we can actually rewrite it as 2 times integral, right? So instead of doing negative h to positive h, I'm going to do a half of it. So I'll do 0 to h. And since it's an even function, the other side produces exactly the same value. So we just multiply by 2. All right, so we have ax squared plus c. All right, then find an antiderivative. So it's antiderivative a, just a number, so I'll just put a here. Antiderivative x squared would be 1/3 x cubed. And the antiderivative c is cx. And we're going from 0 to h. Right? So if you plug in h, so you have a 2, and we still have 1/3, and a, and you have a h cubed, plug in h for x, plus ch, and minus, if you plug in 0, it's all 0, so this is it. Right? So I'm going to do a little bit of manipulation because I know what's going to happen. So first, I'm going to distribute 2 to both of these terms. And at the same time, I'm going to actually pull out the h from both terms. So I'll put the h right at the end. All right, then we're going to have, actually, yeah, let's do it here. All right, so you have 2/3 and you have a AH squared, and then you have a plus 2C, right? And then I'll pull out the 1/3. Sorry, I should have done it before. So pull out 1/3 so that I don't have to see fractions here. If you pull out 1/3, you have a 2AH squared. And if you pull out 1/3 from 2C, you're going to get 6C because you have to multiply by 3. So you have a 6C times H. All right, so we have this expression, and we want to think about how to express this expression using f of x0 and f of x1 and f of x2. All right, so let's do that. All right, so we have to create. Let's look at this portion right here. All right, how do we create that? All right, so we have AH squared and AH squared here. So we can create 2AH squared by adding those two. So let's do that. So if you add f of x0 and also f of x2, then you see that you have two of these guys. You have a 2AH squared, right? Then you have a negative BH and the positive BH, they cancel out because they have the same magnitude with different sign. And you have a 2C. So you have 2C, right? So we're almost there. We got the first term, and we have 2C instead of 6C. So we need 4 more C's here. So you have f of x1 is equal to C. So you can just multiply that by 4 and add that on. So you can see that if you do f of x0 plus 4 f of x1 plus f of x2. This is going to give you exactly, because you have 4 more C's, you have a 2AH squared plus 6C. Right? Now we have a formula. So you have, so here is, this is the formula here. If you want to find the area under a parabola, all you have to do is you have a 1/2. Oh, actually, not 1/2. 1/3, right, which is here. So this expression inside can be found by simply adding f of x0 and 4f of x1 and f of x2, right? Then multiply by h, right? So this is the formula we're going to use to explain Simpson's rule, right? All right, that's it. I hope that this was clear.